All right, let's continue with this notion and go to a couple of examples where we're trying to find perimeter and eventually the area of figures in the coordinate plane. Here's an example. We plotted these 3 points, so I didn't put parentheses around them. Mr. Davis, you're getting sloppy. Excuse my post-nasal drip. The sniffles are from my post-nasal drip. So we have the point 0, 1, the point 5, 4, and the point 2, 6. We formed this 3-sided figure, some kind of a triangle. I'm not sure if it's a right triangle. We could figure it out once we found the slope of these 2 lines. We know the slope, and we can do slope the calculating way or the counting way. Calculating says a change in my y, 4 minus 1, so it's 3 on top. For this one, the slope would be 4 minus 1, which is 3 on top, and 5 minus 0, which is 5 on the bottom. Okay. So we know that this line, DE, has a slope equal to 3/5. So let's check this one, EF. Okay, it goes from the change in y is 4 minus 6, that's a -2. It's a -2 on top. And then the 5 minus the 2, 5 minus 2 is 3, so it's -2/3. So you can see 3/5, -2/3, they're not negative reciprocals. Therefore, this angle here, DEF, is not a right angle. Okay. So we know that this is now not a right triangle. Okay. Using our knowledge of things to prove things. Since we found the slope of these 2 lines, let's go ahead and find the slope of this third one. That's a 6 minus 1, so it's a 5 on top. And 2 minus 0, so it's a 2 on top, 5/2. So we have one line with slope of 3/5, one with 5/2, and one with -2/3. But that doesn't help us find the perimeter, but it does help us to get there. Okay, because we're using that same kind of thinking, that change in the x direction and the change in the y direction, that'd be our big triangle. Okay. Change in the x direction, which in this case is from 0 to 5, so that's a change of 5. And the change in the y is a change in the x direction and a change in the y, 4 minus 1. And we're going to take those 2 things and square them. So we got 25 plus 16 makes 41. So we know that this distance, d to e, is square root of 41. We do the same thing for the other sides, for e to f. You can see that the change from on the x is 5 minus 2, that's how we got the 3. And the 4 minus 6, that's how we got the -2. Square those 2 numbers, 9 plus 4, square root of 13. So now we know that EF is the square root of 13 units long. Similarly, for the DF, we do the exact same thing. We say, okay, the change in my x is 2. The change in my y is 6 minus 1 is 5. 2 squared plus 5 squared is 29. And we're going to take the square root, and that tells us how long DF. And then we could add those 3 quantities together. That's where you punch them in your calculator, get the decimal approximation, round it off to the 10th place. And I just did these as off my head kind of approximations. For square root of 41, it's about 6.5. I may be off on that. Square root of 29 is about 5.2. You can check it on a calculator. Square root of 13 is about 3.8. Sum all that together, and you see that that perimeter for this green triangle is about 15 units long. Okay. Now let's take an example for the area. Okay, so let's look at this one here. Okay, so we graphed this thing. Looks kind of like a square. We could prove it was a square by finding the slope of this line and finding the slope of this line and seeing if they are what? Negative reciprocals. Well, I didn't put any number. Well, I did put numbers here, but I'm just going to do this the way I would if I was on my graph paper. Up 3, 1, 2, 3, 4, 5. So we know that this line has a slope of 3/5. Okay. M equals. Slope of MJ is 3/5. So let's check this one. It goes, to get from this point to this point, I have to go down 1, 2, 3, 4, 5, and to the right 1, 2, 3. So this has a slope of -5/3. And what do you know about these 2 numbers, -3/5 and -5/3? Yep, they are negative reciprocals. Therefore, they are perpendicular lines. That makes this a right angle. And then we just have to check to see what the slope is on this line, and we could do it the fast way, the slow way. 1, 2, 3, up 3, 1, 2, 3, 4, 5. So it has the same slope as this one, 3/5. Therefore, this line is parallel to that one. And if we got parallels, if this is parallel to that, that means this has to be a right angle. And if these are both right angles, that means these have to be right angles. That means that this line has to be parallel. So by finding pieces of information, finding our slopes, we can then prove that this figure is a rectangle. Prove a rectangle. Now, my suspicion is that it's actually a square. The only way we could find that out is if we know these distances. Okay? And we find them out by using our distance formula. The change in x, 1, 2, 3, 4, 5, and the change in y, 1, 2, 3. So the distance of LK is equal to 5 squared plus 3 squared. Quantity square rooted equals the square root of 25 plus 9, 34. And we do that same process for these sides. And we know already that's going to be 5 and 3. Okay, that's why it's good to find that slope, because then you got half of your work done. Square that number, add them together, and you've got the distance. And it happens to be the same as this. So we know that this side and this side have the same length. I'll bet you that this does too. It's also 3/5, so it's going to be 3 squared plus 5 squared. Square root, it's going to be the same thing. So all 4 sides we now know have a length of square root of 34. So we can easily find the perimeter, which is equal to 4 times the square root of 34. A little bit less than 6, so it's a little bit less than 24. So maybe about 22. We can punch it in a calculator to get the decimal equivalent. Now for the area, you have to remember our area formula for a square. Area formula for any rectangle, any parallelogram, is base times height. And for a square, since the base and height are the same thing, it's whatever the side is squared. Makes our life really easy in this one, because we're going to do the square root of 34 quantity squared. That's going to be our area. And when you square a square root, you just remove the square root. So 34 square units is the area for this figure, like that. And that's how you go about these things. Remember, finding your slopes. You can either do it by figuring out what these coordinates are and doing the subtractions and making your fractions, or you can do the counting. They're both legit. If you were just given the points, you better know how to subtract. And then once you've found that slope, those are the numbers you're going to use in your distance formula. You're going to square that number and square that number. Add those two quantities together, and that'll tell you how long that length is. Okay, slope, distance formula, Pythagorean theorem, they're all related, and you can find perimeters and areas of rectangles and other figures if you can use that stuff. Lesson 2, module 2, lesson 1. That's where this is all coming from, and that's what you'll be working on Friday, Thursday, Friday of this week. All right, module 2, lesson 3. Module 2, lesson 3.